Let's talk about documentation. The goal of documentation is to accurately report how you went from the raw data that you collected to research results in the form of visualizations and statistical tests. Optimally, these instructions should be in the form of executable code, but at a minimum, a written description of the exact steps you took to clean and analyze your data is necessary. Let's use making graphs in Excel as an example. First, download the workshop exercise files linked on this slide. Once you unzip the file, you should see an Excel file in the folder called Height Country. Go ahead and open this file. Now try writing a verbal description of how you would make the graph in this slide. What steps would you need to take? Feel free to pause this video now and take a few minutes to do this. So if you open the Excel file, it should look something like this. And if I was going to try to reproduce the graph from the slide, it looks like my data is in pretty good shape, but I need to go to the Insert tab and then go to this bar graph symbol and select this first option. And it looks like it automatically identified which data we need, which is great, but there are some changes I would need to make to the graph to make it match the one on the slide. So I just clicked into the chart title so that I can edit it, and I'm going to use my mouse to select everything, and then let's see, the title was something like weight by country for males and females. Okay. We also need a legend, so I'm going to go up to Add Chart Elements and go to Legend, and I'm going to put it on the right. I don't really like these labels here, so I'm going to go in and edit them in our data. And that will update them in the graph as well. We also need access labels, and we can do this. Okay, we need to click on Chart Tools to get that option visible again. Click on Add Chart Elements, and then let's do the primary horizontal title first. So I'm going to type in country and hit enter. And then we'll do the same for the y-axis, or primary vertical. So this was going to be height, and I believe it was in centimeters. And then hit enter again. So that gets us pretty close. How did you do with your graph? Was describing the steps easy or difficult? Do you think someone could make the exact same graph based solely on your instructions? By now, you've probably realized that documenting how to make an Excel graph is harder than it looks. You could avoid all that hassle by automating this process. Learning how to code takes time up front, but makes documentation fast and easy to repeat. I have a script to make a similar graph in R, so if my collaborator wants to see how it was done, I can send her the script and she can run it on her own in about a second. If you open the example R project in RStudio, you can go to this R script called heightplot.r, and then to run the script, hit Ctrl A to select all of the text, and then Ctrl Enter to run it. And it will produce the graph. Easy, right? Unfortunately, it's not that simple. The R language and its packages change over time, which can cause your code to break. To achieve reproducibility, you have to record additional information about your analysis, such as what software you use and what versions and settings were used. Luckily, these questions can be answered using the session info command in RStudio. If you go to the console, which is the lower left-hand window in RStudio, and type in session info, and hit enter, you can see that this will give you information about which version of R you're using, as well as what operating system, and it'll show you which packages were loaded with the script that we were using. This hints at the idea that reproducible research is not just about sharing data and code or software, but also information about the computing environment. I want to mention a few tools that are available for sharing the computing environment necessary for code to function. These include electronic lab notebooks like Jupyter Notebooks and containerization software like Singularity and Docker. Packrat is a tool for bundling all of your packages and dependencies in R, and Binder is a way to share your data, code, and an interactive computing environment in a browser. These kinds of tools are becoming increasingly common as the importance of computational reproducibility continues to grow.